Don't fool
No.
us.
I know it'd be funny because you'd be like in the middle of class and somebody would say, "F this."
Yeah. My statistics class that happens maybe about 2 hours after you guys. There's a guy in my class, and I mean, I'm pretty sure he's got a sailor's mouth. He curses like no other. And I know he was playing around, but he made it look like every time I cursed, he had a really bad problem with it. He gave me this nasty stank eye every time. I'm all like, dude, really? Really?
Loosen up, man.
I know. And then everybody laughed when he gave me the face. So I was like, really, dude? Really? I'm pretty sure you cuss more than I do. All right. So, for those of you, actually, hold on. I accidentally closed my my chat box. Okay. Okay. So for those of you who need to talk to me through chat and need to stop me for some reason, do it. You guys can unmute yourselves and ask me a question out loud. Pretend this is just class.
Okay.
You are. This is class, right? Pretend you're in class. Stop really loud if you need to.
Okay. Oh, you know me. I'm very vocal with my questions, so don't worry about me.
Oh, we know you, Robbie Fizzle. Okay, so tum-tee-dum-tee-dum. Okay, so today we've started to play around with exponentials for a little bit, right? Today we're going to actually learn about how to graph them. Okay, so what I want to do.
That's on 117, right?
This is on 117. Yep.
Cool. All right.
Okay.
Cool.
There is the warm-up section here for everyone. But what I want people to do, I want people to try this out really quick, just as, okay? The one thing I do want to, what was that? We good?
Yep.
Okay.
Good.
Okay. I thought I heard somebody wanting to say something.
Oh.
That's why I wanted to stop really quick to see if anybody had a question. Whoa. All right. So the one thing I want to give people is one of the more. So we're going to get into more of these exponent rules. But the one that I want to get to right now is this one. Actually, I should write it in red so that people can see it, huh?
Yeah, most definitely. Red's better.
So there's this thing going on now. We have a exponent that is negative. Got it?
Got it.
Okay. What do we do with a negative exponent? So it turns out we can turn it into this thing right here.
Isn't that a plus?
Right. So what we did was we grabbed so it's a negative exponent. So instead of carrying around the negative exponent, you could put 1 over the positive one.
Okay.
Got it?
Got it.
So I'm going to do the very first one.
Sounds good.
Okay.
Yes.
Whoa. Whoa day. There we go. So this really is also equal to 1 over 6 to the 1, which just so happens to be just 1/6. You guys see how that worked out?
Yeah.
Okay. Let me do number 2 for kicks and giggles. You guys ready?
Oh.
Same thing, right? It's going to be 1 over, this is the thing that's in the inside. So that's the thing that is going to have a positive exponent now. So it's going to be 1/3 to the 1 power.
1/3.
So this is going to be 1 divided by
3, right?
nuh-uh. It's going to be 1 divided by 1/3. I think I know what you were trying to say, Rob.
Okay.
Cool?
Cool.
So now, this one has a little bit of a trick. So at this point, what we did was we wrote it in that method, right?
Right.
But we can still simplify it. So this is equivalent to, huh?
That's your self-echoing.
Oh, that's my self-echoing. Haha, okay.
Yeah.
Yeah, you're echoing pretty loud.
I know.
Trying to say something?
So this is equivalent to 1 divided by 1/3, right?
Right.
So I think a lot of you guys have already done this already. So that 1, we can grab that, turn it into 1/1.
Mm-hmm.
How do you change division of fractions?
You add, right?
Multiplication.
Right. So it turns into a multiplication. There's something that had to happen before that, though.
Plus it.
Wait, you said what?
So when we turn a division into a multiplication of fractions, what did we have to do first?
Oh, you have to switch. You have to multiply like 3/1, like that.
Right. So this one, the tail end, we have to rotate it.
Yeah, rotate and then multiply.
Right. So we have to do 3/1. The first one stays. So now we have this, right? 3/1.
Which is equal to 3.
Right. So multiplication of fractions works the easiest.
So why is this even a thing if it's like this, if it's this easy?
It's much more, it becomes a little bit more useful. There's more. So this is just like the very, very basic stuff. Make sense?
Yeah.
Uh-huh.
We use this a whole lot more when we get into graphing.
Okay.
Does that make sense?
Yep.
Yeah.
Okay, so yeah. How about you guys try up to 6, 7. So let's try those 8 for now. Yeah?
Mm-hmm.
So I'm gonna give you guys, let's try, you guys wanna try 5 minutes?
Sounds good.
Yeah.
I'm down like Crestor. Sounds good.
Down like Crestor, huh?
Yep.
Are you gonna say catch up?
That's all gone.
Okay, we have chats. Let's see.
Yeah, people want to know if it's being recorded. People want to know. Sorry, they're late.
Yeah, Damon, don't worry about it. I actually didn't start lecturing till maybe like what, 5 minutes ago?
Yep.
Yeah, just about.
Yep. Just about.
I was letting people figure out the online situation.
Yeah. Which is hard, man. This stuff's like.
Yeah, I know. It's gonna be. I understand this is gonna be really hard, especially because this is not what you guys signed up for. But we'll get through it.
Got it. Oh yeah, no. I'm not saying we won't get through it. We'll get through it loose like Red Goose, but we'll be fine. Don't worry.
Robbie Riddle. Robbie Riddle. Okay, so for now, I want you guys to try. And this is the last thing I assigned, Damon. From number 1 to number 8, I left a couple of examples there with the rule for everybody to try it out. Cool?
Okay.
And I'm still looking at my chat. So if people want to ask me something specific.
Okay. So 3, 4. Okay. So I have a question. Anything times a negative is a positive, right?
Say it again?
If anything's times minus a negative, it's a positive, right?
Right.
Okay. This is okay.
So if you have a negative exponent,
Right.
that means you can grab that negative exponent
And plus it.
and do 1 over, and that turns it to a positive.
Okay. That's hard. Dang, this
Yeah,
stuff's
you got this, Rob. You got this.
okay. 214. Let's see. Perfect examples.
What did people do over the weekend?
Let's see. Went to the store to get some ketchup and it's gone. Who would thought?
Huh?
Who would thought people hoarded it like it was hand sanitizer?
You are right, Rob.
Everything is gone.
I know, everything is.
Thankfully, my wife and I, we went to do our like weekly shopping trip. Did that maybe about a week and a half ago. So we had no need. We have everything. We got all the toilet paper we need.
Good, because there's no more right now.
Yup.
Row, row, row.
Yep. Exactly. It's terrible. Zombie apocalypse coming. Grab your guns. Everybody says the gun line stores are going up.
Right.
That's horrible.
It is horrible. People are like buying guns instead of buying like stuff they need. It's terrible.
You guys want to hear something funny?
What?
I don't know why people are buying hand sanitizer. Soap is much better.
No,
Right?
hand sanitizer is better because you're like out in the middle of somewhere and you can't find a sink. Hey, what do you do?
Sanitizer is worse.
Right. Hand sanitizer is the worst thing you can buy.
Yeah, you're basically just rubbing your germs even more everywhere on your hand.
Well, it does kill some,
See?
but soap is what kills the most.
Yeah.
But people are dead set like, we need to buy hand sanitizer.
That's right. Soap does kill the most, like burnt toast, though. You're right about that.
The most like burnt toast, huh?
Hmm.
Robbie Fizzle, I'll be waiting for your mixtape.
Hello.
Hello.
All right, awesome.
Who is that sultry voice?
This is Damon.
Yeah.
Okay, let's see.
We're locked in our room. We're locked in our houses, right? We gotta find something to entertain us.
Yeah, I thought about just coming on here and just being a complete asshole and being petty because of all this. There was like nothing you can do about it. I'm just gonna be a piece of shit and just screw around in here. But
I know. And I know what you're saying, but no, we're actually doing work. We're doing okay for now.
yeah.
So
Yeah, but this is sad.
I know.
This is like the movie Outbreak. Sad.
Yeah.
They were gonna blow up that little town, and they finally found that cure.
Well, let's hope that don't happen.
Well, I know that's exactly the way that everybody's purge shopping. Heck yeah, it might happen. You never know.
Purge shopping. That's a good way to put it.
That's what I told my dad last night. There's gonna be a purge next.
Huh?
I said that's what I told my dad last night. There's gonna be a purge next. The electricity.
You think so?
Yeah.
Heck yeah, because people be crazy these days, man. You should see soldiers. People fighting, people getting arrested.
You know, you are correct. I just hope it doesn't come to that.
I hope not either. It's terrible.
Yeah. That would be with the problem.
Yeah, you should have seen the arrest in San Francisco. They got it on camera. It was funny. He was like, I'm not okay what this guy has, booting through stuff.
Really?
Yeah.
Wow. That's
What page is this?
this is something or other. 117?
It's 117. Yeah, 117.
Yeah.
We're all on page 117, everybody. We just did
thank
1, 2, 3, 1, 2, and 3. And then he
Okay.
wants 4, 5, 6, 7, 8, 9, 10, and 11, 12.
Well, just up to 8. Come on.
Oh.
My bad. Up to 8.
All right. So I just want to do 2 of them. What 2? Well, 3 of them. How about we do 3?
Can we do 5?
Yeah. Five's the hardest. Yeah, 5 does sound hard. Good idea.
Okay, so we got a DJ request for 5.
And
What
3.
We did
and
3.
3 is a good one.
We did 3, didn't we? Or was that 2?
No, we just did 1 and 2.
Good one.
Oh, 2. Okay.
So 5, 3, and what other one? Let's do
How about 8? No?
Yeah, let's do 8. That's one I was looking at.
Yeah, 8's good.
Okay, you guys ready?
Yup.
Lost.
Okay, you're lost. I can dig it. I can.
117.
Huh?
Oh no, not that. I mean, I'm just writing it down. I don't quite get it. I literally, as soon as I woke up like 8 minutes ago.
Oh, it's okay, man. Don't feel bad.
That is a great.
I was trying to figure out this whole thing too.
Like you can literally wake up, roll in the direction of a computer, and if so long as you do that before class, you're on time.
No, you can't.
Yeah, that's pretty much how I felt. It was like I was awake at 5 and I just got sleepy at 7. I was like, I'm pretty sure I'll wake up in time, and I did.
Yeah.
It's hard. I don't even think I can roll over to a computer. That's why I grabbed my phone and was like, oh shit, class. And I was like, oh wait, we don't have class. I was like, oh yeah, yes we do.
No matter what, I mean, you guys should have your packets or at least some piece of paper out in front of you guys. So I'll put the problems up just how we usually do in class. It's up to everybody else. It's up to you guys to sort of make sure you keep up. Yeah?
Yeah.
Got it.
Okay, if you need me to slow down, I can slow down.
No.
But we have to keep going. So that means we have to keep trying problems. If you guys get them wrong, that's great. Let me know.
Okay.
Okay. Number 3.
Right.
Number 3. We are going to treat the top and the bottom separately, and then we're going to put them together a little later on down the line. So, 3 to the negative 2 is also what?
Positive.
Positive what?
Positive.
Isn't it a positive 2 or something?
Positive 9.
Close. So what did
Positive 6?
what did the rule up here tell us to do?
Oh, we divide.
So you can turn it into a division, right?
Right.
But in the process, the exponent becomes positive.
Right.
So that means the top, I'm going to make that 1/3 squared.
Oh, that's right.
That uses the rule from up here. That uses this thing up here.
Okay.
Got it?
Got it.
And then the bottom has the same issue. It has the same thing, right? So this is going to be now 1/2 squared. Make sense?
Mm-hmm.
What's 3 squared?
I'm just gonna go with the random number.
9.
5.
That's
9. 5. So 3 squared is 9, right? But that's on the bottom, so it's 1/9. What's 2 squared?
4.
4. So 1/4. Got it?
Got it.
Okay. We have to do the same thing that we did.
Or no?
Huh?
Will we reduce that anymore or no?
Nope.
Okay, cool.
You have to clean it up though, but there's no reducing here.
Okay, cool.
Okay. We have to do the same thing that we did for the previous problem over here. So that thing that we just now have written is equivalent to 1/9 divided by 1/4.
Mm-hmm. Right.
What do we do with this thing?
You multiply by the reciprocal.
Right. So this is going to be the 1/9 stays times we need the reciprocal of that 1/4, which is 4/1. We have to flip them. And now it's a multiplication of fractions, which is this kind. So what's my answer?
No. I think it's gonna be like 25 or something.
Mm-mm.
Okay.
So how do you multiply fractions?
Just go straight across.
Right. This is just go straight across. So this
This is 4/9.
exactly 4/9.
Right.
And that's the only part I understood.
All right, done. So it's okay, Damon, that you're sort of a little lost because this is brand new. This stuff, that stuff right here.
Yeah, I was gonna wait to the end to ask about the equation.
So it's basically just the rule for at least for exponents. If you have a negative exponent, turn it positive using the.
That's all.
That's it. So let's keep using it. Let me go to number 5.
Okay, 5 is good.
Okay. So notice how this thing is on the bottom already, right?
Right.
So we're going to use our newfangled formula, the one that we wrote down at the very top, this one right here.
Mm-hmm.
Let it loading. This one,
Mm-hmm.
the a to the negative n one.
Right.
We're going to use that one just on the that bottom portion, right?
Okay.
So the 10 stays.
Okay.
1 over. We'll go through my parentheses.
So 1/5
Uh-uh.
or the
The
it's
one,
1/5 and
the
then
one-
square.
It's going to be 1 over 5, what?
25.
Right. So
Oh.
that's the thing that changes, right? It's going to be 1 over, I think somebody said 25. Correct. I'm drawing this out a little bit so that everybody sees the steps.
no, we're good. We're like Taco Bell gone wild. We're good.
Okay. Cool.
Cool.
What is 1 over 20? Sorry, 1 over 5 squared?
25.
Right. So this is going to be 10 times 1 over 25.
Could you just leave 25 in there, or does it always have to be 1 over 25?
So, like I said, I'm drawing out the steps so that people don't get lost. So, but you're right, Damon. We can. We're gonna go ahead and switch those right now. So, what I want to do, I want to look at this portion right here. Right.
Right.
This is equivalent to 1 divided by 1 over 25.
Can we reduce that or no?
Maybe. So I can turn the 1 into 1 over 1. I have the fractions again. What happens?
You
Then
divide.
it'll just be 25 because you have to put the 25 over 1. And then
Right.
after that, it'll be 10 times 25.
Right.
Correct.
1 over 1 times 25 over 1, which is 25.
Okay, cool.
Now, that was this thing right here. Right?
Mm-hmm.
This reduces down to 10 times
25.
times 25 is,
250.
and we are done.
So there's a lot of yelling going around for the past like 2 minutes. I missed what happened to the 10?
So the 10 we separated out. We didn't deal with it until this step right here.
So you just ignore it until you undo the 1 over 25?
All that happened was we cleaned it up before we actually multiplied the 25.
Yeah. Okay.
Got it?
Yeah, sort of, but I get it.
Yeah. I know the sort of feeling. Okay. You guys ready for number 8?
Yep.
Okay. I'm going to not exactly ignore, it's going to carry on. But the over 2, I'm not too concerned with it right now. I want to that thing up first. What is that? What is
Oh,
-2? How do we change that?
Divide it into itself.
You put it 1/3 and then a +2.
Right, 1 divided by 3 squared.
Oh, it changes places. Okay.
Right. So notice what we did, right? We just used our rule. That is it.
Yeah.
okay, cool.
What is 1 divided by 3 squared?
1/9.
1/9. So this is now 1/9 divided by 2.
Okay. Interesting.
Okay. Now we have the same thing happening again, right? So we have this going on. 1/9 divided by 2/1.
You flip it? Or did you flip it already? No, you flipped it already.
Not yet, actually. So you see how we have it in a division form? So let's change it to a multiplication.
So that'll give you 2/9.
How? So there's going to be 1 times
You
what?
multiply. Oh wait, no, it's not. It's gonna be 1/18
Mm-hmm.
How?
because you have to multiply across, but you have to switch it. So you would put 1/2 and then equal it, and you multiply straight across.
Right. So 1 times 1 is?
It's 1/18.
And then 9 times 2? And we are done.
Yes, cool.
Does that make sense?
Yep.
Okay.
It's actually easy.
I know.
It's getting there. It's getting there.
So is there ever going to be any point in this where we reduce at all, or do we just keep the last answer as is?
How about this? For this next part, I want everybody to try 9 through 16.
Okay.
So here you might need to do some reducing.
Okay.
Okay. Sounds good. I think.
I'm going to give you guys maybe a good 5 more minutes with it.
Cool.
So, Julio, as far as lectures go,
Uh-huh.
it just left my head. Oh, as far as lectures go, since we started a little bit late, is it gonna hang over like after class a little late, or is it gonna
No,
end on schedule?
I'm going to end it on schedule.
Okay.
A large portion of this, right? I wanted people to sign in, get comfortable with everything. Does that make sense?
Yeah.
So that's why I didn't start on time. I actually started a little later than usual. Cool? Cool beans?
Sounds good to me. Can't complain here.
All right.
Oh, man.
I am still here if people want to ask me questions.
Because it's the internet. It's a whole new, different version of socializing.
Yeah, I know.
We do WhatsApp.
No, thank you.
Like kind of like the same thing.
I don't have a WhatsApp. That's why.
You can FaceTime people and
Huh?
do the same thing we're doing.
You can what?
It's the same thing we're doing, but a little bit differently on WhatsApp.
Yeah.
Yeah. It's not. It's nicer though. So I heard. I don't know. But this is nice too. I like it. It's weird.
It is so weird.
It is. It's like we're all sitting here, but we're not. Kind of reminds me of those dating apps where you go in the videos and be like, "Hi, I'm such and such."
Yeah, before they made the VHS videos, they did
Yeah.
those online videos.
Dude,
I remember those.
I can't remember what movie it was where they kind of like showcased a bunch of those. Like back when people needed to submit a video.
Oh yeah.
41st dates.
Yeah, I think that's what it was.
Yeah. You actually needed to submit like a
44,
video.
40-year-old virgin. My bad. Sorry.
Yeah.
41st dates.
That is a movie though.
Yeah. The Adam Sandler movie.
Adam Sandler.
Clear, I have a question.
Yeah.
For number 11, is the bottom number gonna be like a really big number?
Yep.
Okay.
All right, back to
I have a
business.
question too.
Yeah.
So since we're not we're not in the class, we can't really do the group work. So how does that work?
Yeah.
I'm gonna have to move it individual.
Okay, so then does that mean class is gonna end early?
No. I am going to be online no matter what.
Uh-huh.
And it'll have to be sort of like you guys do your group work individually,
Mm-hmm.
but I am going to be here to answer questions because the group work is a little difficult for you guys to do sort of all on your own.
Okay.
Does that make sense?
Yeah.
Yeah, that does kind of make sense because it's gonna be hard to just do it all by yourself, and then like on top of that, you won't have any help.
So that's why I am going to be online with everybody.
Can we just skip it?
You're fine.
So that's a no.
Yeah, that's a definite no.
You're killing me, Smalls.
You'll be all right. You will be all right.
Now this is just gonna compile more work for me.
It'll be fine, Rob.
I hope so, because then I won't have. Well, then I won't. I'm gonna need help. It's gonna be.
Rob, you worry too much.
Well, yeah, because when I'm not in a math lab where I'm getting the help I need, yeah, of course. And then they shut down the school, and then that's going to be even more messier because they shut down the school, and then to God knows how long.
Well, we know for how long. Till April.
I forgot.
Supposedly. Who knows? They could extend it.
Yeah, exactly. So how long are we shutting it down for? I forgot.
Till April 12th.
To the 12th? What the hell? I thought it was to the 7th.
It might be, actually, no, you're right. I think
Oh, I was about to say, they're playing with my emotions.
Yeah.
I saw a post that Trump said that the coronavirus is gonna stay around till like July and August.
Yeah.
So I feel like they're gonna cancel school for the whole semester because that's what other colleges are doing.
From what we know, the other colleges are moving to online instruction. So Stanford, Berkeley, all the other community colleges. So Alameda, who else? All the other districts have been moving to online instruction. So they're doing the same thing we are.
Okay.
Can you scroll up to number 1, please? Just so I can look at it real quick. Okay, thank you.
Yeah.
So April 12th. Okay, cool. Because I don't like this. I want to get back to school.
Yeah, I'm the same too.
And I dig it.
Okay. Wait, this thing is. No, it can't be. No.
Julio, for 13, 3/4, and then it has -2 on the outside.
Yep.
Do we have to put the 1/3 and then the 2 by both of those numbers?
Yes.
So it would be 1/3 squared and then 1/4 squared.
Oh, I see. No.
No.
Mm-mm.
Okay, I'll wait till you do it.
Okay, so what time?
All right, let's hope I'm doing this right.
Okay,
I got it.
I got it. So we have class discussion. Okay. What pages are we turning in?
Huh?
What pages are we turning in?
For this, you guys would be turning in your group works with
Okay,
119,
got it.
20, and then your lab assignments, which is 121,
Got it.
122, and 120. No, let's just go up to 122. I'll let you guys skip page 123.
This is what's due today?
No, in a week from now.
Oh, let's say, damn. Mind. All right.
Okay. Well, I'll try to get you those pages, and if I can't, I'll have them for you back when school starts on April 12th.
All right.
So all the lab assignments you're allowing us to give you late, or is it just for the recent ones?
Let me see. Well, I'm gonna have to create an online submission thing for all the assignments from here on out.
Okay.
And I think I made you guys take a picture. Remember that of one assignment?
Yeah.
Oh yeah.
So I'm gonna go ahead and do that for the rest of them.
Okay.
Yeah, that's the only way I'm gonna get you guys to turn in work and not stack me up for the end of the semester.
Well, you're gonna have to wait for my stuff till the end of the semester because I don't know how I'm gonna turn that stuff.
I want you to try to turn it in online using the picture.
Okay, that's a little difficult, but I work with it.
You got it. You got this. There's like a little camera button. You just take a picture.
Right.
Take a picture from Canvas, and that's all you gotta do. Just press enter and send.
Yep.
Are you gonna have a tab open for us to like send it on or submit it on?
I'm gonna make all of the submissions now online.
Okay.
So there's gonna be an assignment for each one of the things that you need to turn in. Got it?
Okay, got it.
Yep.
Sounds good.
All right. So how about this?
What?
Let's see. How about we do these and then we'll go on break?
Sounds good.
Okay.
Break.
Which two do you guys want me to do?
Do number 9, please. I got stuck on that one.
Actually,
Yeah,
I'll do 9 in addition to an extra 3.
okay.
All right.
Yes. Do 9, 14, and
Actually, I want to do 13 too.
So
um,
9, 13, and 14.
how about 16?
We can do 16, sure.
All right.
You guys ready?
Yep.
All right.
Okay. This is a rule that I didn't give you guys. Ha ha ha. But it's a simple one. Okay. My tablet's a little glitchy. There we go. Okay. So actually, let me write it in magenta. Whoa. Let me change the size of this pen really quick to this.
Okay.
So a to the 0 is always equal to 1. It doesn't matter what a is. It can be any number you can think of. If it's to the 0 power, it's always going to be 1.
Okay.
Right.
So this is basically 2 times 1.
Exactly.
Okay. Wow, I spent way too much time thinking too hard on
Me too.
that.
And I don't blame you guys for it. Technically,
I
remember
just multiplied the 2 and the 3.
which one?
I said I just multiplied the 2 and the 3 because I thought the 0 just was nothing.
Yeah. So this one is going to be, so from this rule, right?
Right.
Equal to 1.
Mm-hmm.
Which is 2. Okay.
Just that. We are done.
Right on. Easy peasy.
Mm-hmm.
Got it?
Right.
All right. Let's move on to 13.
Okay.
Ready for it?
Yep. We're ready.
All right. So same thing happens, right?
Right.
Oh, I need black. Black pen. There we go. Okay. Same thing happens as before. Before we just had a good old flat number. Now we have a fraction, but that doesn't change the rule. It's always going to be 1 over 3 over 4 squared.
Mm-hmm. 3 or 4. Mm-hmm. 1.
Got it?
Mm-hmm.
Have I got it yet?
Yep, we got it.
Okay. So now there's this thing, right? I want to clean that up.
So we got to reduce it, right?
Yep. So what is 3 4 squared? What does that mean I need to do?
You need to do 3 over.
Multiply across.
Okay. So specifically that means, so when I do a square like this, what does that mean I need to do?
You need to times it, right?
By?
By that number.
By itself.
By itself. So it's going to be 3 over 4 times 3 over 4.
Oh boy.
Then you cross multiply. 3 times 3 is 8. And then 4 times 4 is 24.
Close.
Okay.
3
Do you
times
flip? Do you flip this at all?
not in this case because it's already in a multiplication.
All right.
No, this one you just multiply straight across.
Yep.
That's just 9/16.
Right. 9 over 16. So we just get to multiply straight across.
Yep.
Okay. But we're not done yet because all we did was change 3 over 4 squared, right?
Right.
Now we have this going on. 1 over, I know. Got it?
Got it.
Got it.
So now we have this going on, right? 1 divided by 9 over 16.
So it's basically 1 divided by 1, and then divide that by 9 over 16.
Right.
So what's the overall answer?
And then now you
16.
just do the reciprocal.
Right.
Oh yeah, I forgot about that.
Times the reciprocal, which is 16.
16 over 9.
Which is?
So the answer
16
is
nines.
69.
Right.
Do you care if it's improper?
Nope.
Okay. That saves time.
Yeah, it does.
Got
So
it?
it equals 9. Yep, got it. Can you just give us the answer without the fancy math?
Oh no, I need the fancy math.
People
I'm
need
sorry.
Okay.
I had to see where I screwed up.
Yeah.
Okay, so 14 Got it.
Okay, you guys ready?
Yep.
We're going to treat both of them separately.
Okay.
So, divide. What is what?
Oh, you got 1 over 5 to the squared positive.
Right?
Yeah.
And then on the bottom, you have 1/2 to the 4th positive.
Mm-hmm.
Right.
Ooh, no, that's not correct.
Over 5 squared,
Mm,
and then 1 over 2 to the 4th.
So
and
would
then
that be
after that, does it become 1/25 over 1/16?
Right. So, I'm going to clean this up a little bit. 1 over 25 divided by 1 over 16. I'm going to put these in parentheses just so that you know what's what.
Mm-hmm.
Cool?
Cool. Is that the final answer?
Not yet.
No.
All right. Too small. All right.
Okay. So now we have this going on, right?
All right.
Right.
We have 1 over 25 divided by 1 over 16.
Right. And
Right.
then you have to do the reciprocal and multiply, and you'll get 16/25.
Right. 1 over 25 times 16 over 1, which is equivalent to 16 over 25.
Mm-hmm.
Ooh.
That's the final answer, right? 16 over 25, right?
That would be the final answer, right? Can you
Cool.
reduce it anymore?
No.
No.
Nope. We are done.
Okay, cool. All right.
Okay. You guys want to try the last one?
Sure. Sounds good to me. Let's get this party started.
Okay.
So that becomes 1 over 10 squared positive. Oh, wait. 16. Whoops. I thought you said 15.
Which one?
I thought you were doing 15, not 16. My bad.
Going 16.
No, we're going to do 16, but
Okay.
so we ready for this one?
Yeah.
Okay. The 10, we don't need to touch it yet.
Right.
1 over 2 to the negative 3 can become what?
1/8.
Right.
Right. 1 over 2 cubed, and Damon already said it, 10 over 1 eighth. Got it?
Mm-hmm.
Got it.
Ooh, no, I did that wrong. So why doesn't 10 become 10 over 1? Because you already know ahead of time it's just going to be 10 because it's 1 over 10.
Right. Right. So we have this going on, right? We have 10 divided by 1/8.
Mm-hmm.
Which becomes what?
You put the 1 over the 10, right?
Right.
Or the 10's on top.
There you go.
Okay, so it's 10 over 8. No, I'm sorry. The answer is 80.
Right. So here is where you do the flip, right? Times 8 over 1. Straight across, right?
Right.
I haven't lost anybody yet, right?
No,
No.
no. Go on, keep going. We gotta get the answer.
And these two are multiplied.
Mm-hmm.
This is 80 over 1,
Oh, 81. 80 over 1. Okay.
which is 80.
80. Yeah.
And we
Well,
are.
let's say 80 rather than do all the extra stuff.
Oh my God. It's part of the rules, Rob.
All right, killing me, Smalls. Okay, so
I know, right?
I know.
All right. Let's go ahead and take a break. I'm going to let this run.
I have a quick question.
Yeah.
How do we make our own what is it? Make our own Y's or X's.
What do you mean?
It says without technology, create a graph use of Y equals GX equals 10 over 2 5 to the X.
Oh, you can do that with your calculator. So I'll show you guys how to do that in a little bit.
Okay, cool. Sounds good.
Cool.
That's what I'm gonna need help with. But other than that, we're good to go. We're in like
Cool.
So I got a question. Wait, let me figure this out since I know I was doing it wrong.
Okay.
1 second. So for number 10, do you just figure that as is, or do you set to the 1 over 1/2 squared through or cubed? Oops.
Say it again, Damon.
For number 10,
Yeah.
is that going to be written out like 1 over 1/2 cubed, or is that just going to be 2 cubed? I mean 1/2 1/2 cubed.
Number 10. Oh, this one.
Yeah.
So
I got 1/8.
this becomes what?
That becomes 1 over 2 cubed. How's it?
Right. Which is
Oh, okay.
Which is equal to 1/8.
1/8.
So the only time you need to do when do you need to put the 1 over 1 whatever, like you have a regular whole number above the denominator, which is a fraction. When do you have to do that? When you're getting away from negatives?
So you're talking about something like number 16
Like number 14.
or 14.
Yeah, like 14, 13.
So
Right.
you only put it in both fractions when there's a negative
Okay.
exponent on both of them.
Right.
Who the fuck keeps calling me?
you're at school. You can actually use that as an excuse now.
Can.
Be
Even
like, all right,
home.
cool. Hey, we should get up at 6 a.m. and do this.
Oh my God.
Come here, baby. Come here.
people?
What was that?
When do they let people go for break?
10:40.
40. Really? 40?
Sometimes it's like a 10:35.
No, but just now for today.
Oh, I don't know. Probably like last 5 minutes ago.
I don't know. This is crazy.
Oh, man, we have to graph with this stuff now.
Yeah, on page 119 too.
But that's all of today.
It's nasty looking.
I know.
It is. Well, I mean, the graphing portion of it is because like we don't know what we're gonna get for the graphing portion of it because we
I feel
don't
like
know.
we're just plugging it in for the graphing part.
But it says complete a table though and create a graph of y equals gx equals 1025. So I don't know how to do that.
We're gonna do multiple ways of getting answers for these things. So
Cool.
in the meantime, everybody should be. How about go ahead and open up Desmos.
Okay.
Oh boy. What you want, dog?
Okay, I'm in Desmos.
All right, Desmos. Beautiful free math.
Yep, exactly.
Math has never been beautiful.
I know math isn't beautiful.
It's never been beautiful.
Nope, math is not beautiful.
All right. So to pretty much function this equation, we're just typing in the y equals f of x equals 3 times 2x. And it should come out as long as we plug it in, right?
We're
Yeah.
correct.
Oh, awesome. No,
So
stop.
we're just gonna graph that.
Stop.
Who is that?
It's my dog.
Oh, doggy wants to play.
Sir, I got a question.
Yep.
So we're just gonna graph that one.
Yep.
Oh, so, okay. Okay. So what? I just hit y equals. Do I do the 10 and then on Desmos do I hit the So I just do y equals 10 parentheses and then the -5 or -2 and then I put the equals and all that.
Yep. Well, I'll check it really quick. I think we're doing.
Right. So I just put y equals 10 and then 2 divided by 2 no get rid of 10 parentheses and then put 2 over not minus 2 over 5 and then -2 and then put 10 not 210 -2 over 5 and then -2 or how do I How do I put the power in on Desmos?
I'll show you guys right now.
Okay. Cool. Sounds good. Okay. Yeah, sounds cool. Thank you. Because that saves me a whole lot of time. Because even though I'm in Desmos right now, like, yeah.
You have Desmos up in front of you right now. Stop it.
Me?
Yeah. Or Robert.
Yeah, I did.
All right. You know how there's like that ABC button on the bottom left?
Yeah.
What's wrong with you? Sounded like my dog was about to get sick. All right. So don't click that. So you see on the top part, upper left, there's like X, Y, A squared, B.
Yeah.
All you gotta do is press the A over 2. And that should put
Okay,
it there.
got that. It just says 2.
Yep, that's how you power it. That was your question, right?
How do I type it in? Do I just type in like Y equals and then the square?
For which one?
For the first one that we're doing, like where it says -2, so 10, and then the parentheses 2/5, and then to the negative squared. So do I just put that all in for Y, or how would I do that?
Let's see.
I think it's time to actually do it.
It's time.
You want to take a break, huh?
No, there should be no break because we're online.
That's
Should be working overtime.
Yeah, some jobs are killing people or firing people. It's sad too.
I heard that. People are getting fired. Well, not fired, laid off because, well, there's no money coming in.
Exactly.
Yeah, I know. That's sad.
I don't really think anybody thought about the next few weeks of them actually doing this rather than them just, hey, this is what we should do.
Our parents might get laid off too because their job is bringing in the money.
So I hope nobody's parents get laid off.
I know mine neither. But their job requires a lot of business. So without business, shit. Same thing with my sister. She might get laid off too because she's in the travel industry. So
Oh, wow.
yeah, so like
Yeah,
nobody's
nobody's traveling.
so it's hard.
Yep.
Okay, so do I just hit Y equals the 10 to then the parentheses 2/5 to the -2?
Hold on, bro. Slow your roll.
Okay, well I need to know so I can grab this stuff.
I know. So, all right. You ready to come back? Seems like people are ready to come back.
I don't think anybody left.
No, there's
Everyone just left their break.
everybody left during break. Okay, so first of all, let's answer the questions that are given at the very beginning. Let me do a new share.
Okay.
Share the entire screen. There we go.
All right.
Cool.
Cool.
That's cool.
Let me get my calculator. Hold on.
Can I do this on T183 or do I need the T84?
The buttons are pretty similar, so I think you should.
Okay, got my calculator. All right. Okay. Teacher?
Yeah.
Okay, cool. You're still there. Okay, good. I thought I disconnected you.
All right. So what I want to do first is just use our calculators just to find 2 to the 14th. And show you guys how to use exponents on your calculator.
Right.
I said just flat out, how do you do exponents on a calculator? I think we've already done a fair amount of these already. Does everybody see my mouse on my screen?
Yep.
Okay. See this caret on your calculator? Just a sort of like a thing that's pointing upward.
Yeah, it says T and it says H to it. Yep, I see
Yep.
that.
That's the button we're going to use. So if you have, Damon, for you, since you're using an 83, it won't look as pretty, but it's the same way.
Right.
Mhm.
I the A4. Right.
Okay, so if we do, so for example, for number 1, we want 2 to the 14th. So 2 to the 14.
Why 14? Because it says 10, 2 over 5, parentheses, -2.
We're doing class discussion number 1 at the very bottom of page, what is that? 117.
Oh, 117. Oh, okay.
Got it?
Got it. Now
Okay.
I'm back.
We hit enter. We get that thing. So 2 to the 14th.
Oh, 1,000. Oh, 16,384.
Got it?
Got it.
Okay. So now,
Should write this down.
2 to the negative 14th is equivalent to what? Let's just go
Sorry.
rule.
You just put a slap of negative on it.
Well, yeah, so in this case, what we're going to try to do, we're trying to find this number right here. But we're going to do it. Come on. My computer's acting up now.
Uh-oh. I hope you don't cut it out, because then we won't get the rest of it.
Oops.
Yeah.
Oh,
We want to find that thing. 2 to the negative 14th,
Right.
right?
Right.
And we're going to try to find that using the number above it.
Okay.
So 2 to the negative 14th is also what? If we use our rule from the very beginning of class.
Oh, we write it in the correct decimal form, so it's 2.14, right?
Nope. What?
Um,
So how about using that negative rule that we use here,
Oh, up top, right.
this thing? So what does that mean?
2 to the 14th.
Huh?
1 over 2 to the 14th.
1 over 2 to the 14th.
Oh, okay. Got it. 1 over 2 to the 14th.
1 over
14. Okay.
Got it?
oh, okay. I see what you're wanting us to do now. Okay.
Now, what is 2 to the 14th?
That's what we're trying to figure out.
16,384.
Right. So then this becomes 1 over 16,384. This is we're done.
Okay.
So we leave that as is.
As is. Right. So this is actually the exact way of writing it. Right?
Mm.
You plug it into your calculator. It'll give you some randy, funky decimal number that is basically an approximation. Does that make sense?
Yeah, that makes sense.
So what do I mean by that? So let's go back to the calculator.
Good.
So turns out that caret that you use, right, 2 to the, lets you plug in a negative value. So I can put negative 14.
Right.
Does that make sense?
Yep.
And if we hit enter, we get that thing.
Right.
Just how the
Yeah.
Yeah.
text shows, right?
I didn't get that.
What do you mean?
I got 0.000061035.
It's the same thing. So that,
Do I change my thing?
no. So you see that E minus 5 thing?
Mm-hmm.
That means there's, that means there's 4 zeros in front of it.
Ugh.
So mine's right?
Yours is correct.
Okay.
So if you look, right, the
Mm-hmm.
numbers are still the same for you.
Mm-hmm.
You see that?
Yeah.
Yeah. So don't fret. Don't worry. Got it?
Yeah.
Got it.
Okay. So actually, the question's asking for the answer. So the actual legit answer for the correct decimal form, thing that you just said, 0, 0, 0, 0, 6, 1,
Okay.
0, 3, 5, 1, dot, 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 dot. I'm not going to do the rest. Okay. Got it?
Got it.
Okay.
Wait,
Now,
go back up, please. I didn't get all of it.
Hold on, dog. Don't walk on my laptop.
dog wants petty. That's why.
I've been this whole entire time you've been talking, but as soon as I stopped to write, he's like, "Hey,
Hey,
let's stop."
I wanted to stop. I didn't tell you to stop.
Thank you. You can continue. Got it. Thank you.
So now what we're going to do, we're going to attempt to graph this thing.
What page?
Oh, boy.
I don't want 18.
Yeah.
Yep, 18.
All right. 18. All right. Cool. Just so I'm with everybody. All right.
Yep. Okay.
All right.
So the graph that we are going to try to make a graph for is that one, 3 times 2 to the x.
Right.
And we are going to try to fill in a table first.
Right. Just like on 19. And see, that's why I got confused. So I can work with this one. Okay. Cool.
So we're going to actually try to make a graph of this.
Okay.
Yeah?
Yeah. Sounds good. So f of x.
Okay.
Cool.
So let's start. So if we plug in x equal negative 2,
Right.
it's going to be our answer. So let's write it out. Let's write out the math that goes in there.
The fancy math. Got it.
So it's going to be 3 times 2, and now our x is our negative 2. So it's going to be, let me rewrite this so it goes a little lower. 3 times 2 to the negative 2, which is equivalent to?
3 times 2.
What do we get to do
3
with
times 1 over.
It's 3 over, and then it goes 1/2 squared.
right? 3 times 1 over squared.
2. Yeah, positive.
What's 2 squared?
That's 4.
That's 4.
So changes to 1/4.
So my final answer is
3/4.
right. So it's going to be 3 over 4. Does that make sense?
Yeah.
Okay. Let's try negative 1 now.
Okay.
So it's going to be 3 times 2 to the negative 1, which is
3 times 2 over 1.
3 times,
1 over 2.
which is equivalent to
3/2.
3/2. Next one, 0. 3 times 2 to the 0 power, which is
3 times 1, which is 3.
You guys are getting this.
Sort of. Yeah.
Sort of. Okay. 1.
3 times. What was the rest of it? 2 to the 1.
Which is
Which
6.
is 6. What's the next one?
2.
3 times 2 squared, which is equal to 3
3 times 4, which is
times 4,
Which is
12.
12. Okay.
Rob, we good?
Yeah. Sort of. Good.
Okay.
So now we have to graph all that.
Now we got to graph it. So an axis is given there for you guys to try to graph it. You guys want to try to go ahead and do it?
Yeah.
Okay. I'm going to go ahead and do it right with you guys.
Cool.
So,
Okay. So there's that little dot.
you guys have graphed it already.
Yup. One. Okay. Right there. And 2. How many points are there? There's
5 or 6.
how many circles did we do? How many points did we do? 1, 2,
6.
3. We did 6? Okay.
Yep.
Okay. Okay. Got it.
I had to reset the Zoom thing.
Huh?
So I had to reset Zoom because everyone sounds like a robot to me. So how are we supposed to graph 3/8, 3/4, 3/7?
You sound like a robot to us now.
How are we supposed to graph those points?
Yeah, I'm just gonna write in the chat.
So, right. So these 3, maybe 4 x values. These 3, 4 x values, they should be doable.
Okay.
It's the first 2, these 2, that are going to be really difficult because you're estimating there. So if you don't tighten off, don't worry too much about it. Got it?
Got it.
Sort of.
Okay. So the very first question. What is the y-intercept of the graph?
The y-intercept would be the 3/4, wouldn't it?
So what's the definition of the y-intercept?
Oh, isn't that like the slope? That's like the x, right?
Well, yeah. Well, the y-intercept on a graph, what does that look like?
Oh, that's if it's going up or down, right?
Isn't it the starting point?
Right. The other one, it's a y-intercept, right? It's when it crosses the y-axis.
Right, the y-axis is the starting point, right?
Right. So if we look at our graph, it crosses our y-axis right there.
Right.
3.
Yep.
All right.
Got it? So
Got it.
y-intercept, it gives us the point, actually, it's right here.
Right.
So that point is 0, 3.
Okay.
Got it?
Got it.
Right. 0, 3. Got it. 0, 3. Got it.
Okay. How does our graph behave? Why doesn't it have, first of all, why does it have, doesn't have any x-intercepts?
Because it gets small, because it decreases in value, right?
What do you mean by that?
What? Like it decreases.
Yeah, but what do you mean by that?
Like, what do you mean? What I mean? Like the numbers, instead of like going up, they go down. They decrease. They
So,
fluctuate.
so why does that mean it has no x?
I don't know. I'm lost.
Not too far off, Rob.
Come on, Rob, you got this.
Got this, Rob.
Well, I don't know. Like it just because I guess because the numbers fluctuate so much that like it can't have a x or a y an x intercept.
Not quite. This is a hard question. I know it.
Yeah, it is.
Is it only because they only give you X, so you don't have Y? You don't have a.
Let me ask you guys this. Does it ever cross the x-axis? So if you look at the graph.
Right.
Yeah?
Yeah, we see the graph.
Does it cross the x-axis?
No.
Does it look like it ever will?
No.
Nope.
So it's not decreasing, it's increasing.
Yes. But so what I'm asking you guys is the other direction.
So it's going up.
No, the other direction, going to the left.
Oh, going
It's
to the left.
gonna stay on the X. It's gonna stay on the X axis.
Right. It's gonna sort of like hug it.
Yeah.
Does that make sense?
Right.
It'll hug it, never touch it.
So did that answer the question?
Yeah.
Yes.
Well, let me ask you guys this. How about I do this over here? I want to specifically look at, whoa. Okay, so my tablet's getting a little glitchy now. And now I can't erase. Woo! Okay. I want to look at this thing. 2 to the x. I just want to look at this.
Right.
Is there a number I can plug in that will turn this negative ever?
No.
Does that make sense? No, there isn't. Right? So if we do 2 to the negative 10, 2 to the negative 100,
Right.
2 to the negative 99999, right?
Right.
According to our original rule,
Right.
it turns it into a fraction, but it never turns it negative. So
Okay. So it always stays negative.
it's never negative. It always stays positive.
Negative.
Oh,
Never.
always stays positive, right. Always stays positive. Man, this stinks.
I know. And moreover, right, our rule
Right.
tells us that these things, right,
Right.
they get turned into fractions, right?
Right.
Really, really small fractions.
Right.
This is sort of calculus talk here. So when it says describe the behavior as x gets smaller and smaller, that means that we want to see the behavior of our function as x goes to negative infinity. So really, really big negative numbers, right?
Mm-hmm.
Mm-hmm.
And this one is as
So
x.
basically, we're not saying like it's decreasing or increasing. We're just basically saying it's doing what you're talking about.
Yep.
Okay. So it's not like y equals mx plus b. It's f of x equals whatever.
Mm-hmm.
Okay.
So our f of x's are y values. If you take a look at our graph, right?
Mm-hmm.
Notice what happens, right?
Yep.
Oh,
It
Never intercepts.
Okay.
never. Right.
So this line sort of just does this.
Just keep going.
Yeah.
It just keeps going. Make
Right.
sense? And it gets
Right.
closer to that x axis.
Right.
Make sense? So what we say here is our y value. So that's what this is talking about, right?
Right.
Our
Exactly.
y values tend towards 0.
Right.
Got it?
Got it.
Okay. We can solve certain things for now just by estimating or guesstimating using the table or using the graphs. My computer's being really, really smart right now. Okay, so for A, and for A and B, we can use the table that we have above it. Does that make sense? So we can use this table right here.
Mhm.
So when is 3 times 2x equal to 0.5? According to our table, where should that fall?
It should fall in the, I think it's the y or the x axis. Where the?
Wait, can you ask that question one more time?
Yeah. This one. When does this happen? When does 3 times 2 to the x equal 0.5?
That's probably, can you go back up to the table? Between -1 and 0?
So 3/2 is about 1. Whoa. 3/2 is about 1.5, correct?
Right.
And then 0 is 3. So 0.5 or a half isn't in there yet, right?
Right. So
Right.
it's a -3.
So
Huh?
would it be between the -3 and the -2?
Yeah.
So what is 3 divided by 4? What is that as a decimal value?
3 divided by 4?
Right, but what is that as a decimal?
0.5.
0.75.
75. And then 3 divided by 8?
3 divided by 8 is 3.37. Sorry, 0.37.
0.37.
Mhm.
Does that make sense? So our answer to the first one, right? It's got to be somewhere between -3 and -2, right?
Right.
I'm going to say -2.5 for kicks and giggles for now. Yeah? You see that?
Yeah.
Okay. Robot to
Well, class is over with officially.
you guys have videos going right now. I wonder if that's the case.
What?
Other people have, oh no, people
People are leaving.
no, people aren't leaving. People are just they're on and just watching. Very few of everybody has video sorry, microphones on.
Oh.
Try restarting your thingamabob, your connection.
Oh.
You might need to turn off Desmos. Or how about this? If you have your phone, turn off Desmos, use Desmos on your phone. So in that way you don't sort of use up the internet on Desmos more than this presentation.
Okay. Sounds
Try-
good.
Is it messing up?
I think the connection is slow for people. That's it.
Oh,
Yeah. So no matter what, there's a record. I'm recording this, so you guys should be able to see this later on.
Okay, cool.
Okay.
And then we just sit from Canvas or whatever?
Yep.
Okay, cool.
So 3 times 2 to the x equal 10. Same thing. We're going to use our table. Where does it look like 3 times 2 to the x is going to equal 10?
Between 1 and 2.
We're saying between 1 and 2?
Yep.
Yep.
How's that?
So right here was A, right here is B. Does that make sense? So from 1 to 2, it went from 6 to 12, which means we should have passed up 10 somewhere in there, right?
Right.
I'm going to do it again. I'm going to do x approximately 2.5. Wait, is that too far? 1.5. Haha.
Okay, 1.5. Got it.
Got it?
Got it.
No. What?
You're killing me, Smalls.
I know. Okay, this last one. 3 times 2 to the x equal 150.
Mm-hmm.
A little harder to do.
Right.
So what I'm going to do,
My brain is mush. Ugh.
is continue the table.
Mm-hmm.
See how we have up here, we did 0, 1, 2. We're going to keep going.
Mm-hmm. Keep going. Right.
So this is going to be 3, 4,
Mm-hmm.
5. Let's go up to 7.
Gotcha.
Got it?
Got it.
Okay. What would my value be for 3?
You'd see.
So the formula is still going to be the same. So f of x is equal to 3 times 2 to the x.
Right.
So when I do 3,
Right.
what do I need to do?
Divide it, right?
You do 3 times 2 to the third.
3 times 2 to the third. Got it, Rob?
Yep. 3 to the third. Got it.
And then that turns into 3 times 1/2.
Nope.
To the third.
The power is already positive, so we don't need to do that.
Oh yeah, that's right. That's right.
So what's 2 to the third?
2 to the, that's 8.
8. So 8 times 3 is 24.
That's 24.
Okay. 4.
And then you do 3 times 2 to the 4th power.
Which is
3 times 16. Is that right?
which is
28.
48.
Oh, 48. Sorry.
Seems like we're getting closer.
And then 3 times 2 to the 5th. Okay, this is where I need to get my calculator.
Yeah, no, I get it.
2 times.
2.
So that's 32. 3 times 32.
32. Right.
96.
32.
That's 96. Yeah.
I think 6 might be the end of it, right? So 3 times 2 to the 6 is 3 times 64.
Right.
192.
So between these two,
Mm-hmm.
smack dab in the middle, is it closer to 6 or closer to 5 in this case?
What's the number that we have to get to again? I don't have that paper. Sorry.
Oh, it's okay. Oh, 150.
150. So it's closer to 6.
Probably going to be closer to 6, right? So how about we do just x equals
6.
7, and we'll just say by table.
Okay. Right.
Make sense?
Yep.
Okay. So it turns out these kinds of equations, right, we were just sort of guesstimating for right now,
Right.
right?
Right.
We can get exact values for all of these things.
Right.
And the way that we do that is we set. So, does everybody still see my screen?
Yep.
Yeah.
Okay.
Yeah. We see your calculator and we see the screen. Don't worry.
So I'm going to go to Desmos now. Hopefully I didn't start sounding like a robot to everybody.
Okay.
And what we're going to do is this. The first equation, I'll type that in, x equals 3 times 2 to the x. And we get our graph. Cool? We want this thing equal to 50, or sorry, 150, right? So that's what's going to go in as a second function.
Also, just like on this one, on 119, it's still doing the same thing, right?
Yep.
Okay.
Got it?
Got it.
So
Okay, I have a question.
my y values aren't showing very well. So I'm going to move it so that they do.
Okay.
You guys see that blue line there now?
Yeah.
Yeah. Is that the 150? Yeah, that's 150.
Yep. Got it?
Got it.
Got it.
Whoa. Whoa there. So we now have a way to find these out because all that is the intersection of the two graphs.
Right.
Got it?
Right. Got it.
Now, if you do it on your calculator, let me pull up the calculator. Same process, you just need to plug it in. So let me go turn on the calculator. I'm going to hear this. One of my functions is going to be my 3 times 2 to the right?
Right.
Enter. And the other one's going to be my 150.
Right.
I'm going to hit graph.
Uh-huh.
It'll show me one of my graphs.
Yeah, it'll graph it for you.
Yep. But it doesn't show me my other one. So I need to play around with my window to make sure that it shows.
Okay.
So I'm going to go ahead and make it really close to the current graph that I have here. So my x minimum, I'm going to make it go from -10 to 10. Skip by 1. That's my y's though. I'm going to make that -50. My y max, I'm going to make 250. And notice that my y max is going to be 250. So I'm doing something a bit higher than the line itself.
Okay, you're just doing that for us to see it, right, on the
Yep.
screen?
Yep.
Okay.
My brain is
Everybody
moving.
see my calculator, right?
Right.
And I'm going to make the line go up by 50s. Cool?
Okay. Sounds cool.
Enter. I'm going to hit graph. So now the two graphs, whether you do it on a calculator or on Desmos, should look pretty similar,
Okay.
right? We want their intersection point, right?
Right.
So in Desmos, this is the really neat part about Desmos.
Mm-hmm.
Mhm.
If you tap on the intersection, it'll give you the value.
Mm-hmm.
Cool?
Cool.
If you're doing this on a calculator, right? There is, see that blue calc?
Yeah,
So since it's blue, we got to go second,
right.
and we need intersect.
So alpha, right?
Yep. No, the blue one, second.
Yeah, second. Okay.
Got it?
Got it. A second.
Enter. First curve, second curve, guess, doesn't matter.
Cool. So basically, we do the same thing like we're doing on this page on 118. You can do that with 119 too, right?
Yep.
Okay, so basically you
Oh,
could
good.
say, yeah, just a quick question.
Yep.
So on page 19, 119,
Yep.
you could do the same thing like you just put g of x equals the 6.25 and then graph it and then it'll give you everything else, right?
What's 6.25?
Oh, I mean 62.5, sorry.
Where is this 62.5 you're talking about? Is it the next problem?
No, it's on the next page. 119.
Oh, yeah, yes, you are correct. You are correct.
Yeah.
Yeah.
That's the question. Okay, thank you.
Right. So now, this gives us what we need for the very end of our group discussion, right? We know our value. So x is equal to what we got from over here.
So you just plug that point in. That's what x equals.
Yep.
Okay.
X is equal to 5.644. And we are done.
Sounds
So
good.
just for example for another problem, if it's say for example 5.654, would you want us to round it to 5.7? Or do you want us to leave it as it is?
That's healthy. Does that make sense?
Wait, what? All I heard was that's healthy.
Oh, if you give me 2 decimal values, I think that's a healthy rounding. You don't have to give me much more than that.
Oh, okay.
Does that make sense?
Yeah.
Okay.
So, okay, one more question.
Yep.
Before we leave. So they're asking for the y-intercept. That's the that's where well, that's the 119. Sorry. And the y is the middle, right?
Yep.
Cool. Just being sure. Okay, thank you, sir.
Okay. Class is over.
Well, sounds good. All right. See you later, sir.
Okay. I'll be on for maybe another 10 minutes to answer questions if people need them.
Okay, cool.
Okay.
Bye. There we
So
go.
for today, what's due for today?
119.
I haven't even set up the canvas to do the set to do what's due yet.
Oh, but you told me 119, 121, 120.
So I haven't set up the canvas stuff so that you can turn them in online.
Oh, okay.
So hold off on it for now.
Okay, cool. I like your thinking, sir. You're thinking outside the box.
Okay.
All right.
Okay. El sueño,
What's that mean?
the sleep
Oh,
in Spanish.
so you're taking this? Yes.
Was there a question there?
Okay, so you're taking the siesta. Gotcha.
Yeah.
All right. See you later.
See ya, man. Anybody else? Are you guys all done? You guys cut.
I'm pretty much set for the most part. Just need the assignments that will be due. That's it.
Yeah. So I think for Thursday, I am going to allow a bit of time for you guys to try out the group work because we completely ran out of time just now.
Okay.
Which is okay. I wanted to get people online to make sure that the system worked for everybody rather than just like start lecturing and have people try to connect halfway.
Yeah.
So we might do something similar on Thursday. Again, just to get people connected. I'm glad that 14 people showed up.
Yeah.
I think there was 14, 15 people on this. So this is good. This is working out.
Yeah.
Yeah, and I'm pretty sure all of you guys are in like onesies right now. My question is, I'm not for sure. Number 2. Okay, so, Damon, try to, I know, see if you have extra processes running. So if you go down to the bottom corner, so let me show you, at least for me. So if you go down here, you click that thing, there shouldn't be too much here. That might be the thing that's like drawing resources. So one thing I noticed, I think it was yesterday when I was doing this for my pre-cal. So I play Steam. I play video games, and I did notice my Steam client was on, and it was downloading stuff. It was downloading updates. So it slowed down everything yesterday until I figured it. So thankfully, I figured it out maybe 5 minutes into class.
Okay, Julio, that's it for me. Thank you.
Okay, I'll see you on Thursday, Desiree.
Okay.
Okay. Oh wow. Okay. Yeah, that sounds fine. Maybe because the meeting itself runs regardless of how many people are here. You can have two devices for yourself. So one of them might be the big screen where you just are viewing people, and the other one can be just the audio with the mic. So that way you split up. You're using two different networks rather than one for 3 tasks. Does that make sense? Yeah, I think you might need to do it from your phone. At least get the audio down. Maybe you can get the video from like a desktop computer. Yeah. Well, let's see. Is it the microphone on your computer or the microphone on your phone? All right. We'll try it again on Thursday. In the meantime, try restarting your computer. Try to find anything that's like running in the background that's not supposed to. All right. Damon, Ramiro, I'm going to shut down the meeting. Keep an eye on your emails just in case. I think this went okay. We can continue testing this on Thursday. So I'll see you guys Thursday.